Hey, what's up, Chem students? We are back here, and right now we are talking about using the periodic table. So make sure you have your notes out and make sure you are ready to go. This is the periodic table. It hasn't always looked like this. We've discovered lots of stuff over the years. Honestly, even the last 50 years, we've added stuff, especially down here. Towards the bottom of the periodic table. They're still discovering new things all the time. So some of these heavier ones, the ones down here are pretty unstable, and we're still doing some fun testing with those. So this isn't something that's like always existed. It's not like they've always said, oh yes, exactly, this is the periodic table of elements. It's something that we've discovered over time. If you're interested in the history of it, happy to talk with you more about it. But for now, this is specifically a video about using the periodic table. So let's just give you some key terms. Make sure you're writing these down. The atomic symbol, just so that you know what that is, the atomic symbol is the abbreviated, let's make sure I write that right, the abbreviated, had to pause for a second to remind myself how to spell this word, abbreviated element name. So you might have noticed, my pen's getting a little bit off. The abbreviated element name. So you might have noticed in the past before, like maybe H2O, and thought to yourself, like, okay, like, what is that? Maybe you knew that represents water. Maybe you knew that H represented hydrogen and O represented oxygen. But rather than us writing out every single time hydrogen, oxygen, we have a quicker way of doing this, which is simply replacing, replacing, but just writing the abbreviated element name. So you might be texting a friend, what's something you all would say these days? I'm going to say something old people would say. Maybe you say LOL, laugh out loud. Rather than writing all that out, you just put LOL, okay? So it's quicker for us to write H than to write hydrogen. So the atomic symbol, the abbreviated element name. Don't know why my pen stopped working here, but there we go. What's a texting phrase you guys would use? Yeah, I don't know. Maybe you can laugh at that one if you know what LMFAO means, or you're old like me and you do know what it means. Okay, so the other thing, and just so you can see, sorry, when you're on the periodic table, you see right here, you have the full name. Ooh, the full name here, hydrogen. But you also have the abbreviation, so the atomic symbol, which is just the H, and you see that for all of the different elements here. You also then have these ways that we organize on the periodic table. You have these things called groups, and groups are the same thing as columns. So you have like group 1. Let's make this a little bit thicker. You have group 2, group 3, 4, all the way over here to group 18. Okay, so those are the columns. So if I were to write that in here, groups are the same thing as the columns. Of course, why is this making it so big now? The column on the periodic table, so we call those groups. And then the other thing we have are periods, okay? And periods are going to be the rows. So the period is the row on the periodic table. All right, so we have groups, we have periods, and we have the whole row. So row 1 would be this all the way across, and then it includes helium. Come back over here, this is period number 2, goes all the way across, lithium, beryllium, all the way over here to boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay, so we have total 7 periods. All right, and last thing I want you to know for right now is this thing down here, a family. So families are groups of elements Groups of elements with similar properties. Similar properties. Kind of like how you might look similar to other people in your family. You have some similar traits, maybe visually or maybe the way you laugh or who knows what. So this is a nice periodic table. I'm going to give it to you all, but it's color-coded. So you can see the families with the colors. So the alkali metals has sort of that, I think, yellow-orange look. So we can look here and see that lithium, sodium, potassium, rubidium, cesium, and francium all fall in this alkali metal. So they all act similar, have similar properties. You can see there's alkaline earth, we have the transition metals, so on and so forth. So those are families, and these are just groups of, how did I define it exactly? So groups of elements with similar properties. So you need to know these things. I am going to briefly show you how you find key information about an element, and then we'll wrap up this video. All right, so let's look at carbon, okay? So let's say I, as a teacher, say to you, hey, tell me some facts about carbon. So we're gonna zoom in here to look, actually, let's do the one that they have right here, because it's gonna be easier, platinum. Okay, so if we zoomed in here to look at platinum, we'd find a few things really quick. First things first, we know that this PT is the atomic symbol. So that's just the abbreviated form. So if we see PT, it means the same thing as platinum. So PT, same thing as platinum. What else can we find out? We can find out from the atomic number. This is the same as the number of protons. Okay, the number of protons, those positively charged particles in the nucleus, and our periodic table is arranged by how many protons. So it goes up from 1, there's helium-2, you get 3, 4 for beryllium, it hops across, 5, 6, 7, 8, 9, 10. Okay, it keeps going all the way up until we get to 118 is the highest we have right now. So platinum is over here, kind of falling in the middle. We can see based off its color that it is in the transition metals family. Okay, transition metals. What else can I tell you? If you are a math person, and if you're not a math person, I should say, you can figure this out either way. So the average atomic mass you should have seen from the Build an Atom Simulator is a combination of the number of protons, so protons plus the neutrons equals the atomic mass, okay? And so we get an average because there are different, not every single atom of platinum weighs the same, but the average, I guess, is 195.1. So the way we can figure out how many neutrons are in this atom, if we know that there are 78 protons, I can go like this. I can say, okay, I have 78. Just going to put a piece, you know what I'm talking about, protons. I have some number of neutrons, and my total atomic mass is this 195.1. So I can do that. I can subtract then my 78. And that'll tell me how many neutrons there are. I'm trying to do that quick in my head, and I'm struggling with it, so I'm going to do this. 7. There are... Does that sound right? Yeah, I guess 117. You can check me on the math, but about 117 neutrons, okay? If it is a neutral atom, it's going to have the same number of electrons as protons. So we said that it has 78 protons because of this atomic number. We said that its neutrons is 117 based off of the average atomic mass, and then the math we did over here. And then the electrons, if it's neutral, there'll be 78 of those as well in a perfectly neutral and stable atom of platinum. So those are just some things I can find out about it. I guess last things, you could say that it falls in the 10th group. So the group, again, right here, it is in the 10th group, so the 10th column, and then it is in the 6th period, okay? So those are just some facts that you can tell using this periodic table. A lot more things you could do with it, but this video is already at 10 minutes, so let's end it.